Hi all, today I'm going to explain about my inferential analysis, how I analyze this data set. So first I've taken actually the placement data set, MBA placement data set, and first I have imported the data set using Panda, Sari, CSV functions, and I have just printed the data set to see how it looks. So it includes the gender and the all the marks, SSLC, HSC degree, MBA, E-test, and all other specializations in what is specialization in degree and the HSC and HSC board and SSLC board the students were taken, and the status of the student placed or not and their salaries. Okay, so this is the entire data which is present in this data set. So after that, I actually coded the univariate analysis in a separate file. So in that file, I included the functions for separating the quantitative and qualitative columns and frequency table and some of the univariate analysis as well, and finding out layer and replacing out layer. So this can be I can be used that functions whenever I needed it. So, so I have imported the functions, and here I separated the quantitative and qualitative column and analyzed the univariate analysis. So which include the central tendency, mean, median, mode, and percentile, IQR, min, max, and finding the outliers, etc. Okay. First, we are going to replace the NaN values with the correct value. So for replacing NaN values, first I have to check which is actually handling the missing values. First, I have to check how many missing values are present in each column. So for that, I have applied data set is null and sum. So I have by seeing here, we can say salary 67. So which has 67 missing values. We have to handle this. So for handling the missing values, we have four options. First is replacing with the mean median mode, or replacing with the value as per the use case and the business requirements, or removing the entire column. And the fourth option is using the semi-supervised learning in order to find the pattern of the column and to replace the missing values with the right value. Okay. Okay, so in that salary column, so let me take here. Okay, so in that salary column, we have the missing values where it is actually for the not placed students. So not placed students will be not getting the salary, right? So we have to fill this missing values. We can't able to fill with the mean median mode. So it will be like inaccurate. Inaccurate. It will be like we are keeping a salary value for not placed students. It will be wrong. And second thing, entire deleting the entire column, so it won't be possible because this is the most important feature. Third is applying the semi-supervised learning to finding the pattern and replacing with the salary value. So that is also will be inaccurate. So, so the going with the option as per the use case, we have to replace the missing values. So as per the use case, it is the non-placed students. So for replacing the value, we can go with zero, as non-placed students will not earn the salary. We can replace with the zero. So for replacing with zero, have user fill now salary zero and in place equal to true in order to make the original changes in the data set. So now it has been modified. We have replaced all the missing values. Once we check again, yes, all the missing values of the salary was replaced into zero. Yeah, there is no missing values now. So next, how many of them are not placed? To find this, we can use the frequency. Okay, so the data set column actually contains the not placed and placed student status. We can count their values of not placed students, especially. So the count is 67. Or if you want more information, I have taken from the frequency table, which tells not placed students of 67. And we can also, if you want, we can see relative frequency and groups. So next is find the reason for non-placement from the data set. So for finding the reason for not placed students from the placement data set, I have analyzed how many not placement students were in the data set, which is 67. And I have analyzed is there any specialization reasons for them. So like most of the students are taken marketing HR, which is not placed. And And in degree, they have chosen commerce and management. And other thing, I've analyzed if there is a significant difference between the marks. And in the univariate analysis, I have analyzed if the most of the univariate analysis of this not placed the students. So most of the students are taken the average marks, so average academic scores. So due to the average academic scores and specialization they have taken, might be the reason they have not placed. So they have, so that is actually the reason. So that I have explained here as well. Next, what kind of relation between salary and MBA pass mark? So to find the relation between these two columns, we can use the correlation. Um, Using the dataset quantitative.CORR. So using this, I have find the salary and MBA as the correlations of 0.139823. So which is actually the positive correlation. So we can say that MBA marks is directly impacting the salary. So the person, the students who was getting the higher, have got the higher marks in MBA have the greater chances of getting the good higher salaries. Next, which specialization is getting minimum salary. So for computing that, I have used the group by specialization salary, and from that I have applied the minimum function. So I got the specialization marketing finance 2 lakhs and marketing HR 2 lakhs. So these are the specialization which are getting the minimum salary of 2 lakhs from the placement data set. So how many of them are getting above 50,000 salaries? This three students were getting above, sorry, it is actually 5 lakh. Okay. So 5 lakh salary, the three students are getting the 5 lakhs, and test the analysis of variance between e-test pass mark and MBA pass mark at significance level. So here it is actually analysis of variance between the two groups, and these two groups has actually comes under the marks column wise difference rate. So we can go for the one-way classifications in the analysis of variance ANUVA. So I have taken from scipy.stats library. I've analyzed these both columns and got the probability value of 4.67, so which is less than 0.05. So I'm rejecting the null hypothesis, accepting the alternate hypothesis. So we can say that there is a significant difference between e-test pass mark and the MBA pass marks of the students. So test the similarity between the degree specialization with respect to salary at the significance level. So for testing this, we can use the t-test, and when they have saying the degree and specialization, the different two groups with respect to the same condition salary. So we can say that it is comes into the unpaired t-test condition. And so for unpaired, we use t-test IND from the SkyPy stats library. So in that, I will send the degree and the specialization. So where I have filter out the degree with this science and tech section, a specialization with their salary, and the specialization marketing HR with their salary. So I am sending these both into p-test IND, and I have calculated the probability value, which is 0.07, so which is less than 0.05. So I'm rejecting the null hypothesis and accepting the alternate hypothesis. We can say that there is a significant difference between this degree science and tech domain and the specialization marketing and admission with respect to the salary. So next, we have convert the normal distribution to standard normal distribution for salary column. So I am plotting the a distribution plot, normal distribution plot from the Seaborn library first to see how it is distributed. So it is distributed like this in the normal way, and the salary was with 0 to 0.8 in such cases. So for converting into standard normal distributions, we use the z-square formula, so which is x minus mu divided by sigma. So for that, we have to find the mean and standard deviations for that columns. Okay. and I am calculating the z square, which is I mean minus mean divided by standard deviations, where the I is an each value from the salary column. So after computing the z square, I'm plotting the distribution for the z square. So we can see that so both the data distribution were same, so only the values were changed. So these values make them to be considered within the one particular range. So it will be helpful for the building the model without being more biased. What is the probability density functions of salary range from 7 lakhs to 9 lakhs? To find the probability chances of a student who is getting the salary between 7 to 9, we can put the probability density functions, we can compute it, and we can like find from the graph. So for that, I have inputted the libraries, which is Seaborn, Matplot, Lib, SciPy, Stats, import norm, so for normal distribution. Then I'm plotting the distribution plot from Seaborn and sending the column and KD equal to true, which says I need the normal distribution curve. Okay, and the color green, it is for the normal distribution color. And I'm saying the start range and the end range I need in with the vertical line, which should be red, in order to differentiate the range from the column, not for better understanding as well. Then we are calculating the mean and standard deviation for the, both the columns, as we are need to send to the normal function in the normal distribution to find the normal distributions of the data set. We will send the mean and standard deviation, right? So I have computed the normal distributions for the column. Then I'm actually looping with the ranges and storing the ranges in the list, and I'm actually doing the normal with the help of the normal distribution, calculating the PDF value for values within the start and end range. So after computing the PDF for all, I'm actually summing it, and I got the total PDF, which is the total probability chances between the 7 lakhs to 9 lakh salary. So by running this, I got 0.0059. So we can say that 0.05% chances are there for the students who will fall under the 7 to 9 lakh salary package. So with this analysis, we can say that there is a minimum number of chances, or a minimum number of students who are earning the salary of 7 to 9 lakhs. Test the similarity between the degree and Centec with respect to the e-test and then MBA Basma. That's a good consider. Okay. So same as t-test, we can actually do the t-test here, but here it is only the one same groups with respect to the different conditions, which is e-test Basma and MBA Basma. So we can go with the paired t-test, which is the dependent sample. So for the parallel test, we use t-test real from SkyPay stats. For this also computing degree e-test with that particular specific conditions. Science tech for e-test and degree science tech for MBA. I have calculated the both columns. I have filtered out and I have sent um, in t-test run and computed the p-value, which is 5.51, which is less than 0.05, as it is actually exponential to the power of minus 6, 10 to the power of minus 6. So it is actually the less value, which comes like 0.0005. So which is actually less than 0.05. So I'm rejecting the null hypothesis and accepting the alternate hypothesis. So we can say there is a significant difference between the degree and with respect to the e-test and then MBA pass mark here. The next, which parameters is highly correlated with salary? So to find the which column has highly correlated with salary, we have to compute the correlations for all the columns. So I have computing the correlations for all the quantitative columns using CORR function. So here I can see for the salary we have all the correlation with respect to all the parameters. So here you can say which has the high correlation. Here all the correlation is positive, so the highest correlation is 0.538090, so which is SSLC pass mark. So I can say that SSLC pass mark is highly correlated with salary. So we can also say that like so SSLC pass mark is highly impacting the student salary. Okay, so we can also get an insight. So the student salary is impacted from the SSLC pass mark as first priority, then second will be HSC, and third will be degree, and fourth will be MBA, E-test, and MBA. Okay, so next I have plotted the distribution plot for SSLC pass mark. So how the distribution is there? It is actually the normal distributions. How we can say it is normal distribution in the sense, some minimum number of students were taken with the 40 to 50 marks, and also the top marks scored also it is minimum, so which is 80 to 90, and most of the students were normal distribution, no normal is range, right, 50 to 80. So this kind of distribution we call it as the normal distribution. So these are my inferential analysis for the placement data set column. Thank you.